Okay, so just now we have completed. No, microphone is not on. I know that there is no difference when it is on and when it is off, but I feel like personally good to have this and to speak like this. And also, I found an alternative way. You see, when I have it like this, okay, and when I speak like this, my head is paining over here. But when I have it like this and I speak like this, there is no pain. So we will go with this way itself, and I don't care how I look. This is comfortable, like it's a cushion over here. Okay, so now what we're going to do is, hereafter, I think I'll be using my phone every bit, okay, because here is the place where I have my notes, and also I probably think I've given my tab to someone, and I think that that person will be giving the tab to myself so that they can use tab, like it's kind of bigger screen, right? So it will be comfortable for me to use it to write. Okay, so what we are going to do is, we are going to see types of relation. Okay, so yeah, my handwriting isn't good. Okay, wait. I've never ever used this. Okay, perfect. Which color? This color is itself okay. Types is there, types of relations. Okay. See, types of relations is there, right? It is actually of 3 different types. Okay. First is reflect. No. One more is also there. That is identity. Okay. So first is going to be identity. Which color? That color itself. This color. Okay. Identity. Okay. Identity. Then after that we have reflexive. Reflexive. Then symmetric is there. Okay, so symmetric we have. Then at last but not the least, very important, that is going to be transitive. Where is transitive? No, I don't have transitive. Over here, wait. Transitive we have. For some reason, this transitive is being read as transitive. Oh God. Transitive, transitive. Well, okay. I don't care how the spelling is actually, but I hope you all can just know. Okay, the spelling is correct. Reflexive, it should be V over here. Okay, they should be reflexive. Okay, see, types of relations, we are going to study about these 4 types of relations mainly. Okay, so first is going to be the identity relation. So what is this identity relation? Actually, when a relation is marked, okay, so is marked or is defined, we can say, okay, is defined on set A is said to be identity. Okay, so this is what it is. What does the word on set A mean? On set A means, okay, so on set A means A into A. Okay, when you are having a relationship with set A itself, that means set A is having a relationship with itself. Okay, so set A is having a relationship with set A itself, and also you have to note that if every element of A is related itself only, that only is very important. That word only is very important. Okay. And also this is one condition. Okay, this is what the definition is, and the condition for a relation to the identity, that is actually every element. Okay, so every element of A is related to itself only. Okay. Okay, see, many people like me get easily confused with identity and then reflexive. Okay, actually these two are kind of similar to each other, but they are not same. Most of our questions will be only asked from these three. From this, it will be very rare only. But we will be doing, and also we will be doing some sums. Okay, because if you're just checking out these three, then it won't be correct, and also for me also it will not be good. Like it will not be fulfilled. Okay, I can just like that say those identities and I can go, but it will not be correct. We'll be doing lots of sums if I have here notes. Okay, I don't know whether I've taken lots of sums or not, but at least I've taken 5 sums, that I'm sure. We will try our level best. Okay, so coming to here, what is identity function actually? See, identity relation actually, it's very simple. For an example, we are going to have set A. Okay, so let A be 1, 2, 3. Okay, so now the identity relation for this A is going to be, 1, 1, 2, 2, 3, 3. Okay, and one point that you have to note, that is, other than these 3 ordered pairs, no ordered pair is allowed. For an example, like 1, 2, like that at all, it is not allowed to be inside this set. Okay, inside this subset, that is not allowed, that is illegal. Okay, not like illegal, it is not allowed, then it will not be identity function, then it will be reflexive. Okay, it is here N, but it should be V. Okay, so I hope you have got me. So that is why the word only is very important, because they have to be identity in sense what? Wait, 1, 1, 2, 2. That's it. Okay, let's complete here itself, where the set A is going to be 1, 2. Okay, so here identity in sense, this element, okay, this element should be identity to this element. Okay, so domain should be identity to this element and also to the codomain. Okay, or to the range. Sorry, not to the codomain. Both are same only. Okay, here. Next, here, this element should be identity to this element. That is what it means. And also the word only means that only like this only it has to be. Like other than this, you should not add some other ordered pace. Okay. Now, coming to the case of reflexive. Then, what is reflexive? Okay, so what is reflexive? It's also very simple. That is, which color? Blue color. Okay, na? Reflexive is actually where A comma A belongs to real numbers, and where this is actually A is an element of set A. What does it mean? It means, okay, so wait. Once, okay. I'll just write all these so that it will be very helpful. Okay, so then what is this reflexive relation? Oh. How to get turn on, turn off? Okay, well, I don't know, is there any difference without this microphone or with this microphone or not? I don't know, but I like to say or speak like this, so that is why I'm continuing. Okay, next is reflexive. Okay, so what is this reflexive? Actually, many of you guys would have understood by just looking at this, but we will explain. Okay, for every case, we are just going to take one standard example, that is going to be set A. Okay, where A is equal to 1, 2, 3. Okay, because this is a very simple set, right? So that is why we are going to take this. First is reflexive. Already we have completed identity, where identity in sense how it will be? It will be 1, 1, 2, 2, 3, 3. Okay, like this it will be. Then coming to the case of reflexive, how it will be? Okay. So to the case of reflexive, it will be, see, what does the word reflexive actually mean? Reflexive means that, see, you all know the reflexive image, reflection. Yeah, the word reflection is the correct word. Well, see, exactly opposite to this, like to you, it will be there, right? But it will be you only, isn't it? If you are going and standing in front of a mirror, it will be kind of opposite to you, but it will be you only. Yes, na? So like that only this reflexive is also, which is, this is for the set test there, right? Where, for here, okay, for the set A, the reflexive can be written as, okay, like this, which is, first you have to write this identity, which is 1, 1, 2, 2, 3, 3, okay, like this you have to write. And also along with that, other elements or other ordered pair also can be there. This is what making this reflexive more special than identity function. Okay, here the word like only is not there. Okay, here the word like only is not there. So here you can write like also 2, 1, 1, 2, like this also you can write, or also you can write like 1, 2, so 1, 3, and then you can also write 2, 3. Okay, so like this you can write. Okay, so here actually there will be a doubt for many of us. Even I had this doubt. That is what now we are going to see. That is, okay, so this much at all we need not to conclude. I will erase some. Okay, let it be, no problem. Now what will happen if I exclude any one of them? Okay, if I exclude any one of their ordered pair, that means if I take this 1, 1 out, then will it be reflexive? The answer is no, it will not be reflexive. All these 3 must exist. That means what? This identity relation is there, right? It is going to be a subset of reflexive relation. Okay, you got me? Identity relation. My handwriting is very awful. Identity relation is going to be a subset. Okay, a subset of, no, yeah, it can be also equal to, right? So identity relation is going to be a subset or equal to this reflexive relation. Okay, so this is first condition, only one condition, and that is okay. Next, what we are going to see is we are going to see symmetric relation. Okay, so symmetric is very simple. You all know starfish now? I don't know how. No, I have touched starfish one time. Okay, like this. Actually, starfish will be symmetric. So we will take something that is symmetric. What shall we take? Okay. I hope you all can know what this is. If you all are biological students, then you all would have known this is in sexual reproduction and flowering plants. You'll be studying about this. This is actually symmetric. That means no matter how you cut, it will be giving you the same half only. That means, for example, if you are cutting like this, okay, then this half will be equal to this half. Okay, so there won't be any difference at all. In the half, there won't be any difference. Like this also you cut and see. See, it will be going to give this half, and in this half will be equal to you. Also cut like this you are going to cut. Okay, so actually I have not drawn this that accurately, but this is actually symmetric because this half and this half is going to be same for you. So exactly like that only. Also here you are going to see. What you are going to see? You are going to see symmetric. Okay, what is that? See, if you are having A comma B, then if in case B comma A is also there in that subset, sorry, in that set, now then that is known as reflexive. Okay, that is known as reflexive relation. For an example, okay, for this itself we will take 1 comma 2 and 2 comma 1 exists in this. Okay, then this is reflexive. Okay, then this itself is enough. Okay, there is no such condition like everything should be there, like 2 comma 3, then 3 comma 2, like this, everything should be there. There is no such condition. Okay, only one is enough. Okay, to be reflexive. Okay, to be symmetric. Okay, now I will ask you a question. Whether is this reflexive? Okay, don't worry. I know this white part you cannot see, but under this white part I have not written anything. Okay, like this only. Whether is this reflexive or not? Yes, sorry. Whether is this symmetric or not? Yes, this is symmetric only. Okay, like this you can also add, and also along with that you can add like 2 comma 2. That is also, and then 3 comma 3. Okay, all these are symmetric only, even though these reverse is not there, that is not required. Okay, okay. Then now you answer this another question, that is going to be whether is this symmetric or not. Then it is going to be 2 comma 3. Now whether is this symmetric or not? Is there 2 comma 3? Sorry, is there 3 comma 2? See, you have to check, is there 3 comma 2? That means, see, exact inverse should be there. If 2 comma 3 is there now, then 3 comma 2 should be also there in that set. Then only we will be saying that it is a symmetric relation. Oh, it offs. I don't know why. Okay, so then it should be there. Okay, so then this is what symmetric is. But see, there is not there. Okay, that is not there. What is not there? 3 comma 2 is not there. So inverse ordered pair is not there. So you should not conclude this. Then this is not a symmetric relation. This should be there, as I said. Okay. Now what you have to do is, next we will go. Okay, we will go to the next one. What is that? Transitive. Okay. Transitive. What is this transitive? See, you can say that if in case A comma B is in that set and also B comma C is there in that set, then if also A comma C is there in that set, then that set is known as transitive. Okay, so we have what? We have 1 comma 2 comma 3 na? Okay, so if in case like this it is, A is equal to, like this it is, like 1 comma 3, then 3 comma 2, like this, and then okay, also 1 comma 2 should be there. Okay, so see, you can see that it is there. Maybe if I have this, it won't off often, I think. Let's check. Okay, so it's like this. Now this is actually transitive. Why it is transitive? You can see that there is 1 comma 3 and there is 3 comma 2. Then there should be 1 comma 2. Actually the thing is like this. Okay, if there is a relation between 1 and 3. Okay, and if there is a relation between 3 and 2, then automatically there should be a relation between 1 and 2. Okay, there should be a relation between 1 and 2. This is what it is. Okay, so we have covered the first part. Okay, that is this reflexive, transitive. Then what else did we see? Identity we saw. Then also we saw symmetric. Okay, now another example I'm going to give. What is this? 1 comma 3, 2 comma 2 comma 2 comma 3. Then actually with 3 is this possible? Huh? No. wait. Let us take like this. Now let B be the set which has like elements such as A, B, C, and then D. Okay. Now let's check about it. That's going to be A comma B, C comma D, then A comma D also will take. Okay. Check, is there any relation between these two? A is related with B, C is related with D, A is also related with, A is also related with D. Okay. So this is related like this. You check. 1 is related with 3, 3 is related with 2, then 1 should be also related with 2. Okay. 1 and only if 3 is over range in one place and over domain in one place, then only it is applicable. Like the diagram will be like this, I think. Okay, where this and in this relation, like this now, it's okay. But see, here D is in both this side, so that means there is no relation. Now, the question is whether is it transitive or whether it is not. The answer is it is transitive. Yes. Yes, it is transitive when 3 different or more than 3 or some ordered pairs are there, and when those ordered pairs are not having any relation between them, then they are said as transitive. Okay, we will prove